Good morning, everyone. Hope I'm audible and my screen is visible. So today we are going to start the tutorial session of this course, Principles of Modern CDMA MIMO OFDM Wireless Communication course. So this course is taught by Professor Aditya Nathan from IIT Kanpur. I am a TA of this course. We'll discuss the tutorial session every week at 3 to 5 on Saturday. Like we will discuss the questions based on the lectures taught in that week. So in the first week, basically, it is taught about the evolution of wireless technologies, like how wireless technologies are evolved, and then it was taught about the wireless. Sir, what? The slides are not visible. Is visual now? Is this a problem for everyone or? Then, like it is taught about wireless channel and how the signal is propagated in mediums. And then we have also discussed in this week about relay channel fatigue and then bit error rate performance. So today we will start with some of the questions which is basic, and also we will study some concepts from the first week lectures. So this CDMA, MIMO and OFDM is like basis for the 4G or 5G, even for 3G wireless communication system. So first we will see the evolution. So it was started with like 2G. So the 2G was the work on 2G was going in 1990s, and in every 10 year the next generation of wireless technology has been established. So in 2G, like various technology was there. First was GSM. And what is the requirement of next generation wireless technology? Just to increase the data rate. And nowadays, like there are millions and billions of devices are internetworked, like in Internet of Things. So for that, we need higher bandwidth, higher data rate. So for this, the next generation technology has solved this problem. So initially with 2G, the data rate with GSM was global system for mobile was only 10 kilobit per second. And like in 2G maximum it was achieved in in CDMA also there was 10 kilobit per second. This thing is already taught in lecture, but just I started with the basic, and GPRS was up to 50 kilobit per second. And then in edge it was 200 kilobit per second. So the data rate was achieved from 10 to 200 kilobit per second in 2G wireless system. So after that 3G was launched in 2000s, And like there were different version of 3G wireless technology. So it started with WCDMA. So it was around 384 kilobit per second. Then like CDMA, then HSDPA, HSUPA. So up to like in 3G it was achieved, the data rate was achieved up to 30 megabit per second. HSDPA and HSUPA also, the data rate achieved was up to 35 to 30 megabit per second. Just give me a minute, I will check whether this video is recording or not, because we will also record this video and the video will be uploaded on YouTube. So student can later watch it on YouTube as well. And the link will be provided in NPTEL portal. So after that, 4G, fourth generation wireless technology was established. So in 4G, there is different version of LTE. So LTE was able to achieve 100 to 200 megabit per second, and worldwide interoperability for microwave access WiMAX. In this, the data rate was 100 megabit per second. Nowadays, like 5G and 6G is also there, where the data rate has increased up to gigabit per second as well. So, what was the application of these? Like in the 2G, earlier it was started with like voice transmission and like basic data transmission, like text messages. And in 3G, then later on, like video calling services started. So this required high data rate. Now in 4G, we can do like we can play online game, we can watch HD TV. So for this purpose, like this was the application, and the wireless communication has evolved in every 10 years. So 4G was evolved in 2010. So this is just the evolution of various wireless technologies. So now we will see some of the question. So the first question is the bandwidth of 2G GSM signal is. So the bandwidth of 2G GSM signal is 200 kilohertz. Now we'll move on to the next question. Like these all are very simple and just a MCQ type of question. We'll also see some of the numerical question as well in future. I think the first question is OFDM technology is used in which of the following system? So basically, OFDM is used in LTE in the current 5G and also 802.11, and so it is used in all of these. So this is already taught in the lecture. So OFDM stands for orthogonal frequency division multiplexing. So in OFDM, the carriers are divided into sub carriers. We will study about this in the After some weeks, we'll go into detail of this. So the OFDM is used in all of this. Second question, the bandwidth of, yes, hello. So what is the second option? Like 5G and so OFDM is also used in 5G. 5. Like it is basically used in like 5G NR. So it is the full form is 5G new radio. So okay. The next question is the bandwidth of 2G GSM signal is. So for each signal in 2G, the bandwidth of each signal is 200 kilohertz. The third question is like the waveform employed in an HSDPA system is. So in like HSDPA is the technology in 3G wireless communication system. So in 3G wireless communication system, code division multiple access is used. So the option B is the correct answer for this question. So these all are just theoretical questions. So now coming to the next question, that is based on the probability density function. So in this question, it is asked that the probability density function of the Gaussian random variable x with zero mean and variance 1 is given as. So first we will see the equation of the probability density function. So the equation of probability density function for the Gaussian random variable is given as 1 by a square root of 2 pi sigma square exponential to the power of minus x minus mean whole square divided by 2 sigma square. So this is the probability density function of Gaussian random variable. So now in this question it is asking uh, what is the probability density function of Gaussian random variable if the mean is 0 and variance is 1. So now we will substitute mu is equal to 0 and sigma square is equal to 1. So after that we'll get the PDF as 1 by square root of sigma square is 1, so it will be 2 pi e to the power of minus uh, mu is 0, mean is 0, it will be x square divided by sigma square is 1, so it will be 2. So this is the probability density function of Gaussian random variable with 0 mean and variance 1. The next question is like when a Gaussian random process is input to a LTI system, the output random processes it will be Gaussian. Why? Because when we do the convolution of two Gaussian process, we get a Gaussian. So the option is option number B. Now coming to the question number 6. So MIMO technology is used in wireless system to achieve. So basically what is MIMO system? MIMO means multiple input and multiple output system. So MIMO stands for multiple input, multiple output system. So what does it mean multiple input and multiple output? Means there will be like m cross n number of transmitter and receiver. Like if there is single input single output system, there will be one transmitter and one receiver. So the data rate will be depending on number of transmitter. So if the number of antenna is increasing in MIMO system, then data rate will also increase. Like let's suppose this is our transmitter and this is our user terminal. So what happens? Let's suppose there are multiple number of data pipeline, then the data rate will obviously increase. And if there is single data pipeline, then data rate will be less. So that's why in the MIMO technology is used to achieve the higher data rate. And also, like in MIMO, what happens? The achievable rate or the what you say is data rate is directly proportional to the number of antennas. So if number of antennas increase, then data rate will increase. Now coming to the next question. The peak downlink data rate of 4G LTE system is approximately of the order. So as we have seen in the lecture, like LTE offers 100 to 200 megabit per second. And so in this, which option is correct? The peak it is asking. So like 1 Mbps is less, 100 K, all are less. 10 Gbps is above than the limit. So option B is the correct answer for this question. Now coming to the next question. Consider a random variable x. The function capital Fx of x is given as probability of x such that less than x. So like when we plot this function, like we know that integral of probability density function is cumulative distribution function and the final probability value cannot exceed more than one. So if in the y-axis it is fxx, so like this is the cumulative distribution function and this is the integral of probability density function. So option D is the correct answer for this question. Coming to question number 9. So it is consider a possibly complex vector. So a vector is given, vector x is given as x1, x2, xn. Okay. And the standard L2 norm square of the vector is denoted by, so it is the square of the L2 norm. So that's why the square root will be not there, only x1 mod x1 square plus mod x2 square plus so on mod of xn square. Okay. So how we can write this? So this can be written as x, like the vector x transpose x. Okay. So when you do like the vector x transpose, so it will be the transpose of vector x will be x1, x2, xn. And when you multiply it with x. So what you will get? X1, x2, dot, 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 x of n. So you will get x1 squared plus x2 squared like that. But in this question, the option is in Hermitian. Why? Because if our vector is complex, this is for real, like for x transpose x. If it is complex, then it can be replaced by x Hermitian of x. So for this, option number C is the correct answer for this question. Because transpose is only for the real vectors. But if vector is complex, then it will be Hermitian of the vector x. Now coming to the next question. The digital symbol constellation diagram is given as 1 plus j, 1 minus j. So let's draw this constellation diagram. So x is our real axis and y is our imaginary axis. So 1 plus j, where it will lie? In the first quadrant, somewhere here. So let's make a cross mark. So this is our 1 plus j. Next is 1 minus j. So it will be in the fourth quadrant because the imaginary axis is negative. Another one is minus 1 plus j. So minus 1 will come in the second quadrant. So here it will lie. Now fourth is minus 1 minus j. So both are negative. It will be in third quadrant. So this is the constellation diagram. So here we can see this is the constellation diagram of QPSK symbol because each symbols are 90-degree phase is having 90-degree of phase shift. So option B is the correct answer for this question. Anyway, we will study all this BPSK, AM, FSK, PSK and QPSK in details later. So next we will see some of the concepts of like multipath propagation in the wireless medium. So let's suppose this is our base station. So this is our base station. So here there will trans receiver pair. So the transmitter transmit the signal to the users. So let's suppose this is our user and like there will be different infrastructure kind of thing like tall buildings, trees. So what will happen if a symbol is transmitted, then it will reflect from the buildings. Okay. And just one more thing. I just want to show. And so, but there will be some direct line of sight also, like if the base station is near to the user. So direct line of sight, there will be no reflection. The signal is directly received from whatever transmitted from transmitter directly to the users. And other signals will have lots of reflection. So there are two kinds of signals. So first is the line of sight The line of sight is modeled by Raysian channel, and the second is non-line of sight. So practically, it will be non-line of sight because of the multipath environment. Like there will be different infrastructure trees, and there will be no line of sight components between transmitter and receiver. This is modeled by Rayleigh channel. So we'll study about this. Now at users, like at user terminal 1, there will be superposition of multiple signals. Like as you can see, this signal, and this signal. So there will be superposition of multiple signals. So this is known as multi-path propagation environment.
Excuse me.
Yes.
Hello.
Yes.
This line of sight rising channel is not covered in the lecture. What is this?
Yes, we will study about this
Rising
in
channel.
future lectures. So just for introduction, I am saying Just for
Okay.
introduction, I am saying like for line of sight component, it is modeled using Raysian channel. For non-line of sight, it is modeled using Rayleigh channel. So in future, we will cover both the things in details. Today, we will cover mostly Rayleigh channel. So what is this multipath propagation environment? Like there is superposition of multiple signals on the user terminals. Then it is called as a multipath propagation environment. And signal can be like constructive in nature and destructive in nature depending on the phase. So we'll develop the equation for this multipath scenario. So there will be L multipath component, and each will have delay and some attenuation. So delay is given as tau I. So delay in the ith component and attenuation is AI. Okay. So we can model our channel hi tau as some attenuation AI and delay tau I. Okay. And now there will be L component. So we can do like we can write h tau as summation of hi tau. So these all are already taught in the lecture. So just I am writing, then we'll solve some questions. So now HT is given as the wireless channel is given as like two important factor delay and attenuation, and there will be L component, so it will be summation of AI del T minus tau I, and the received signal YT is given as it will be like convolution of transmitted signal ST with respect to the channel impulse response HT. So this is transmitted signal and HT is channel impulse response. So when we write the convolution formula, so our yt will be integration of h tau s of t minus tau. So this is the equation for convolution of two signal. So now from the above equation, like if we will substitute this value of h of tau, we will get yt as summation of I is equal to 0 to L minus 1 because there are L component AI del of tau minus tau I. As we know, like the integration of impulse function with respect to ft dt will be f of tau I. Okay, because at all other value, if tau is not equal to tau I, the impulse function will have zero value. So this integration will lead to f of tau I. So we can write yt as, like this summation will take it out, ai ai is constant, so we will take it out. So here you can see, like we have to substitute from this property of impulse function, we are substituting t is equal to tau I in the function. So here in st minus tau, we will substitute t is equal to tau I. So this will become s of t minus tau I, because this tau is, if tau is equal to tau I, then only impulse will have value. Like impulse function, as we know, like del of t is 0 at all value except t is equal to 0. So here for tau is equal to tau I, except that for all values impulse function will have 0 value. So we can write it, like simplify this with this equation. So the received signal yt will be finally, like we can write for st minus tau I as, real part of, this we can write e to the power of j 2 pi fc tau I multiplied with e to the power of j 2 pi capital fc t. So this is our carrier signal, and carrier frequency is given as fc, and this is our complex baseband signal. Okay, so we can write yt as the received signal as like complex coefficient ai e to the power of minus j, like here will be minus 2 pi fc tau y multiplied with st. So this is our complex coefficient. And yt can be written as also h into st. So here h is equal to our complex coefficient that is given as 0 to L minus 1 ai e to the power of minus j 2 pi fc tau y. So here like delay is tau y and ai is the attenuation. So later on this can be like we can derive the Rayleigh fading distribution channel. So finally the steps are like we can use the joint distribution equation, and then finally we will get the like these are already taught in the lecture, so you can look from there. So this is the Rayleigh fading distribution. So this like you can see the derivation in the lecture. So now we'll solve some of the questions based on this. In today's lecture, we don't have much questions, like numerical question. It is mostly theoretical. So from next lecture, I will try to keep more numerical questions, so it will be more interactive. It was just the basic introduction today. So which of the following is not a 3G or 3.5G wireless standard? So GSM is the 2G. So the remaining three is the 3G or 3.5G wireless standard. So for this question, the correct answer is option number A. Because GSM is for 2G and remaining 3 is for 3G or 3.5G. The real and imaginary part of the standard wireless channel coefficient described in the lectures are assumed to be distributed as. So these are like assumed to be distributed as Gaussian random variable. The next is the phenomenon in which channel coefficient is constantly changing, is termed as fading. So this fading channel coefficient will have two parts. First is attenuation AI and delay tau y. Now next is the probability density function of an exponential random variable x defined for x is greater than 0 or equal to 0 with mean 2 is. So we know that for exponential random variable the probability density function is lambda e to the power of minus lambda x. Okay. So here mean is equal to 1 by lambda. So mean is given here as 2. So what will be the value of lambda? 1 by 2. So the probability density function will be half e to the power of minus 1 by 2x. So option B is the correct answer for this question. Now the probability density function of the amplitude A of the Rayleigh Fading channel coefficient with average gain unity is. So The polarity density function of Rayleigh fading channel is 2a e to the power of minus a square. We have studied the derivation of this in the like in the first week of the lectures. You can go visit there for further details. Now, which of the following is a 4G wireless standard? So, 4G wireless standard is LTE because HSDPA is 3G, WCDMA is 3G, and GSM is 2G. The distribution of the phase of the Rayleigh fading channel coefficient is the phase is distributed as uniform random variable. So, the distribution of phase is given as 1 by 2 pi, and the interval is from minus pi to pi. So, this is a uniform random variable. So, this is also taught in the lecture. So, this is 1 by 2 pi, and the value of phi is minus pi to pi. So, when you draw this, so from minus pi to plus pi, the value will be 1 by 2 pi. So, this is the distribution of the phase. Now, coming to the data rate of HSDPA that we have seen, it is 5 to 30 megabit per second, and WCDMA stands for wideband code division multiple access. We'll study about CDMA also later on before OFDM. Now coming to the next question, the probability that the attenuation of the Rayleigh fading channel is worse than 40 dB is approximately. So we can write as 10 log 10 a square is less than minus 40 dB because it is worse than 40 dB. So here a is less than 10 to the power of minus 2. So this will become 0.01. And now the Rayleigh fading channel have the density 2a e to the power of minus a square dA. So the limit of a is 0 to 0.01. So here, like when we will integrate it, like we can take a square is equal to t. So this will become 2a dA is equal to dt. So now substitute this value, you will get 2a dA is dt. So e to the power of minus t dt. And t is equal to a square, so it will be 0, and here it will be 0.01 squared. So it will be 0.0001. So after the integration, we will get e to the power of minus t minus 0.0001, and the lower limit will be 0. So this will become, when we will substitute, first we will substitute t is equal to 0 point minus e to the power minus 0.0001 plus, when t is equal to 0, it will become 1. So this will become 1 minus, this is e to the power minus, it will be e to the power of 0.0001. Some mistake is there. E to the power of minus t dt 0 to 10 to the power of minus 4.
In this question, A is asked. We have to calculate A.
Yes, we have to calculate A here. Probability that the attenuation. No, we have
C
to
is the
ask.
answer.
No, no, we don't have to calculate A. The probability that the attenuation of the Rayleigh Fadick channel is worse than 40 dB. So we like first we are calculating A, like what will be the limit of A that is worse than minus 40 dB. Now we have to find the probability that the Rayleigh fading channel is worse. So we have to take the limit of value A is equal to 0 to 0.01, and then we have to integrate this with respect to dA. So after that, when we substitute A square is equal to T, so it will become e to the power of minus T dt. Now the integration will be minus e to the power of minus T will be e to the power of minus 0.
Yes, 40, you can say 40 dB. No,
No, it is worse than 40 dB, so we have to write minus 40 dB here. It will be negative sign. So like 1 minus e to the power of minus 10 to the power of minus 4. I think this is nearly equal to, like, if we do calculation, I think it should match with some answer. I need to use the get calculator, just a minute. So this will be the answer. We can match with by calculating. After this, we'll take some questions, like apart from the lecture.
what is the answer in this? What is the answer in this?
1 minus e to the power of minus 10 to the power of minus 4. So answer will be 1 minus e to the power of minus 10 to the power of minus
Option.
4. Option we
Option
can
is like,
match it.
an option is not clear.
Yeah, maybe option will be different. So this is the answer. So now let's take a question. Like at SNR is equal to 10 dB. What is the bit error rate for AWGN communication system with BPSK modulation? So we have to find the bit error rate of the relative wise Gaussian noise channel system with BPSK modulation where the SNR is given as 10 dB. So when the symbol x is equal to 1, it is declared as minus, like 1 is minus root of p is declared as 1 and plus of square root of p is declared as 0. So this is our BPSK modulation scheme. And here y is equal to x plus n. So x is the symbol transmitted, n is the noise. So like when will the bit error rate will occur? So let's suppose bit 1 is transmitted. So y will be our minus root p plus n. And so bit error will occur when, like if y is greater than 0 and bit 0 is received. So what does it mean? Like bit error occurs if y is greater than 0 and bit 0 is received. Because 1 is transmitted here, so y will be minus root p plus n, and bit error will occur when it is received it as a 0. So in that case y will be positive, so in that case the error will occur. In the similar way, like if 1 is transmitted and 0 is received, then error has occurred. So like if 1 is transmitted means minus root p plus n, and when it will be called as error when it is decoded as 0, like 0 is received. So in that case this will be greater than 0. So in that case our noise will be greater than square root of p. Okay. So the probability of error will be probability of n that is greater than square root of p. So this can be written as, like it will be greater than p by sigma to infinite 1 by square root of 2 pi. This is a q function, e to the power minus t square by 2 dt. So basically probability of error is given as quotient function. So that is q of square root of SNR. So this is power, the signal power divided by the noise power, sigma square. So this is equal to q of square root of SNR. Okay. So now in this question, what is asked? The SNR is given as 10 dB. So 10 log 10 of SNR is equal to 10 dB. So our SNR will be 10 to the power of this 10 will get cancelled to 10 to the power of 1. So probability of error will be q of square root of SNR. So this will be q of square root of 10. So you can like check the value of q table, and this will be the answer for this question. So it will be somewhat 7.8 into 10 to the power of minus 4. For today, we will stop here only. We'll meet in the next lecture, and we'll have the tutorial session based on the week 2 of this lecture session. So thank you everyone for attending today's lecture. We'll bind up here. If you have any question, you can ask. Else we will bind up here only.
The Q table is will be given, or how to see the Q table?
You can check in the internet. Like Q table will be provided, and there will be instruction how to look at the Q table.
Yeah, what exactly the uh, how can we interpret the Q table? This probability calculation.
Actually, this is just the like integral of either you can do the integral of 1 by root 2 pi e to the power minus t square by 2 dt.
Oh.
So this is only the function, but this is like we can get the value using the
So
Q
we
table.
in computed and tabulated in Q table,
Yes, yes,
right?
yes,
Is only the significance. That is only the significance of the Q table.
yes, yes. Actually,
Okay.
we don't have to like do this like complex integral. So for that, we directly like find the probability of error using the Q table where it will be a square root of SNR for BPSK, AWG, and communication system.
Yeah.
Okay, then. So I will like this video is also recorded and will be uploaded on YouTube. So thank you for attending.
So what is the reference book for this course?
Like there is one book for like book from I. Jagannatham sir that from there only he is teaching like principle of
Jagannath.
yeah like the sir have one book. It is a black covered book. I think, but it will be whether available in your library.
Title of the books.
I think the same only modern CDMA MIMO. Like if you search, a soft copy will be available, but not officially. Like on the some of the pirated website, it will be available. Like when you search, like it's not officially, it's not available in free. So that will be not available. But if you search on some like go into some website, you will get it. But I will not suggest that. I will not suggest that because that is not suggestible.
Okay. Anyway, or any peer book, any peer edition or similar book which covers at least 70 to 80% of the syllabus, any book would you suggest?
I need to check like which book is like there are multiple books on this.
Okay, okay. Okay, kindly
From next
post
lecture, I
in
will next
post
lecture. Yeah.
or yeah, next time
Hmm.
also it will be okay. It will be good if any reference book. Of course, this lecture slides and videos all are available readily. If at all we explore some
Like wireless
relevant
communication, like one of
topics
the
related
most
to
like
the
if you want to study complete wireless communication, then the most reputed book is from Andreas Goldsmith that you can visit. And if you want,
so, all right. Next book. Okay, there it is. It is available.
but if you want to visit for this course, then like Professor Adit sir have their own book, so might be it will be available in your library. From there you can check.
Okay, okay, okay.
Okay, thank you. Bye bye.
Thank you.